Hi there, welcome back to the course. In the previous lesson, we discussed about the theory of causal model, how to forecast when you have multiple factors that are accounting to your future sales. As time series comes with an assumption that your forecast is as good as your history. But here today we'll be solving an example where we have multiple factors that influence our sales. So for example, I have taken a dummy data set where we have sales plotted for different month, and along with that we also have how much price change have happened in that month in terms of percentage. So for July the price was dropped by 10%. So this can be for a number of reasons. If competitors are dropping, I am also dropping my price. Second reason can be a discount. So I want to give a discount because there is a festive season. So there is on October also I see minus 20%. Then in December I see price hike. So this price hike can be because of raw material cost increasing, operations cost increasing, or various other reasons. So like this I have plotted price change. And along with price change I have also added a column which talks about the promotion spent in dollars. In May month I have spent $50 for my promotion, and in June again I have spent $50. So there are different months where I am doing promotions. Promotions can be in terms of campaigns, some advertisements, creating some videos across YouTube, Instagram, social media. So this is the column which has the details about promotion dollar spent. So this is till here it's a historical data. The month, sales, price change, and promotion spent dollars. Now we want to forecast for next 4 months, and we have also details about the planned price change. So as you can see in September and August we wish to increase price by 10%. And here on promotion spent we have 50, 0, 50 and $100 to be spent in August, September, October and November respectively. Considering this, now we have to forecast. Now all our previous models we have discussed so far, they used to only consider the sales, historical sales, and in which month it is happening. So that would consider the trend, the seasonality, or any error or residual factor into the forecast. But here when we are forecasting now, we need to also consider the price change and promotion spend, because that is also affecting the your output or the forecast. So let us get started right away. How you can create a multiple linear regression causal model to forecast. So what you need to do, select the historical sales data, go to the data tab, go to data analysis, here you will find a regression option in data analysis tools. Click on it, hit OK. Now once you are here, you need to input the details. First we would start with the Y range. Y is the output, so our output is sales. So we'll select actual sales column fully. Now since we have selected labels here, I have also selected the actual sales cell. Now next is the X. So these are the variables which would influence our forecast. So we'll select the month, the price change, and promotion spend dollar. So these three columns will be selected here. Once you do this, you would like to add the output range where you would like to see the output. So we would like to have the output here itself in the same sheet. You can have the output in another sheet as well. This can be selected when your data set is too big, you have multiple columns and you would like to have a different sheet for this. Now you go and select OK. Now once this is done, you will see the you will see the output of the forecast or the linear regression model. In our previous lessons discussing about the auto regression and ARIMA model, we have discussed extensively about these output, what is R square, adjusted R square. So we won't repeat this again. So I'll directly plot the forecast now. Now this output has given different coefficients for month, price change, promotion spend dollar. There is an intercept, and it has also given an overall R square. So 0.9 R square means 90% of the time, 90% of the data points will be fitted in this, in the equation which would create from this output. Now let me create the forecast equation. The forecast would be equal to the intercept. So let me write down the equation again. So any output y would be equal to a plus b1 x1 plus b2 x2 plus b3 x3 and so on. So since we have only three variables here, so I have taken till 3, which is b3 x3. Now we have to write this equation. Now a is the intercept, so in our case this is the intercept which is here, and this would be the b1, this is b1, this is b2, this is b3. So let me just make it bold so that it's visible for you clearly on the screen. So these are our intercept to form this equation. Y is equal to a plus b1 x1 plus b2 x2 b3 x3. We have discussed this equation in our previous lesson in detail. Now let us write the equation. So we'll start with the intercept. The intercept coefficient, which is this, we'll freeze it because it is going to be same all across. Then plus we take the month or the variable, the intercept, the coefficient of the month, which is b1, this into the month, which is August in this case, we'll freeze that as well, plus we'll take the coefficient of the price change, which is this, which is minus 4.4 into the price change, plus we'll also take the coefficient of promotions into the amount of promotion. So here comes the output. So let me just zoom it again and show you what all factors have been considered. So here you come, and this is the equation. So M19 is nothing but the intercept, which is a, then b1 x1 b2 x2 b3 x3, which is the coefficient and the function. So like that we have considered. So let me go ahead and just see the formula. So we have freezed the intercept, we need to freeze the coefficients as well before we drag them below. Freeze this one. Yeah, so our formula is ready. So this is our forecast for next 4 months, which has considered the price change of 10%, which has considered the promotion dollar spent as well. So considering this, our forecast for next 4 months is this much. So this is it about this lesson. Try to build your own causal model. Thank you and have a great day ahead.